Hey there, and welcome back to Math 7. So today we're going to be talking about applying proportions with similar triangles and indirect measurements. So we just had our quiz, which dealt with a little bit of this as well. We kind of got our foot in the water of it. But what we can do is use this stuff out in the real world. If you can't really measure something, it's too big, you can kind of use similar triangles and measure smaller things and apply proportions to get a good rough estimate of how big these things are. So, indirect measurement is going to use proportions and similar triangles to measure distances that would be difficult to measure directly, so with a tape measure or something. So for this first go here, we've got a dog that is 2.5 feet high, casts a 5-foot shadow. How tall is a street light that casts a 26-foot shadow at the same time of day? H is going to represent the height of the street light. So the street light here is going to be hard to measure with a tape measure or a ruler. So what we can do is use things that we already know or easy to measure. So you may be thinking, well, where's the triangles here? Well, what's going on is this dog casts a 5-foot shadow and is 2.5 feet tall. So the triangle we are making is right there, where the dog is the end of this triangle. So they are similar because just the way it's built. So what we're going to do now is set up our proportion. So I'm going to go from the big triangle to the small triangle. So different color real quick, so red. So here is the side I do not know of the big triangle. And of the little triangle, the corresponding side is right there, the height of the dog. So we're going to build our proportion from that. Actually, let's find our other. So this distance here, the entire distance, will be that length of the big triangle. And of the little triangle, we are only worried about that little part of the distance there. So what we're going to do is set up a proportion in order to figure out how big this is. So I'm going big to small. So the height of the street light over the height of the dog, 2.5, is equal to, all right, so the big triangle here, it's not just 26 we're worried about the entire length. Or wait a minute. Okay, so the entire length of the shadow is 26 feet. Just the drawing is set up a little weird. So this red line here of the big triangle is 26. So we are going to go, 26 to 5. And we get 5h is equal to, remember we're doing butterfly method here, boom, boom. So 5h is equal to 2.5 times 26, I think is 65. And then divide by 5 and divide by 5. So this street light is 13 feet tall. So we used other things that we can measure and similar triangles and applied it to figure out how tall that street lamp is. Alright, so now in the number 2, in the figure at the right, triangle DBA, so let's take a look at the triangle it's talking to us about here. So DBA, so here's the triangle, is similar to triangle ECA. So ECA will be the big triangle. Try to stay out of the way of the blue line so we can see both triangles going on here. Alright, Raymond wants to know the distance across the lake. So he wants to know this side length here, CE. I'll bold it up for us. Alright, so what we need to do is that is going to be our missing side. So we'll call that D for distance. So remember, we're going big triangle to little triangle here. So D over 40 will be equal to so 320 is, or wait, sorry, excuse me, we need to know the entire distance across, so 162 plus 320 will be 482. 482 over, and the distance of the small is 320. So let me say that again. Big triangle to small triangle. So D to 40 is, this entire distance here is 482 to 320. And then once again, we are going to cross multiply. So 320 times D will be equal to 40 times 482, which is 19,280. And then one step equation from there, divide by 320, divide by 320, and the distance is going to equal 60.25, and looks like we are dealing with meters. So it looks like a small lake, but we know that it is 60.25 meters across. Alright, now find the length of the Chesapeake Avenue. So once again, this is all dealing with similar triangles. So we've got our little triangle here in blue and the stuff we know about it. And then we've got our big triangle here in red. So we don't always have to go big to little like I've been doing. We can also go little to big if that makes us happy. So what we're going to do is set this up another way. So we've got little triangle is 4 miles to 8. So little to big. So 4, the entire length here is 8. So 4 to 8 is equal to 6, little triangle here, this length, to x. We don't know that. That's what we want to know, right? So once again, cross multiply. 4 times x is equal to 48. Divide by 4, divide by 4, and we know that Chesapeake Avenue is, looks like 12 miles long. Alright, so if this is a little bit confusing, it helps us to excuse me, draw out our triangle here. So height of the tree, boom. Alright, so the lion casts a shadow that's 0.3 meters here. So there's its shadow. And the tree casts a shadow that is 2.2 meters. So that's going to be this whole length here as opposed to just the 0.3. So we're going to set this up. We've got h to 0.45, excuse me. So big to little, h to 0.45 is equal to, we're doing big to little, so give me 1 second here, sorry. Alright, big to little, h to 0.45 is equal to 2.2, 2.3. Alright, and then we are going to get from that 0.3 times h is equal to 2.2 times 0.45, which is 0.99, it looks like. Divide by 0.3, divide by 0.3, and we get this tree is h equals 3.3 meters tall. So the height of the tree is equal to 3.3 meters. Alrighty, so even though these triangles here are not attached, we've still got similar triangles just because of the way they're built. So this blue one will be the little triangle, and the red one will be the big triangle here. And it's telling us what angles are equal, so we can use that to help us through here. So let's go ahead and let's do little to big, just so we can get some practice at that. So we're going 4 to 8 because those two sides are similar. So 4 to 8 is equal to little to big, so 5 right here to d. Cross multiply, butterfly, so we get 4d is equal to 40. 4d equal to 40, that's funny. And divided by 4, divide by 4, so the distance that we don't know is equal to 10 meters. So what's the distance from the barn to the house? Well, this takes an extra step, right? We know that this is now 10 meters. So that entire distance here is going to be 10 plus 5, which is going to be 15 meters apart. So always be sure that you're looking for steps, different steps here, because had I not took a look at it and realized it wanted that entire distance, I would have just stopped at d equals 10, which would have only been halfway through our problem if I only found that distance. So be sure that you're paying attention here. Alright, so at the same time, a 2-meter street sign casts a 3-meter shadow. A telephone pole casts a 12.3 meter shadow. How tall is the telephone pole? So we need to draw our own picture here. So let's start with my street sign. So my street sign is going to be 2 meters, and it casts a shadow that is 3 meters long. So there's that smaller triangle there. I'm going to call that blue here for my small triangle. Alright, and these they don't have to be perfect, they can be rough, right? And continuing along here, they don't have to be to scale either. So now this telephone pole casts a 12.3 meter shadow. And we want to know how high the telephone pole is. So I'm going to go from big to little this time. So big shape to little shape. So we've got h over 2, big to little, is the same as 12.3 to 3, big to little. And then final step here, cross multiply, we get 3h is equal to 24.6 when I multiply these two. Divide by 3, and this telephone pole is 8.2 meters tall. Alright, so even if we're just given a definition of something, like here, we can draw our own triangles in order to figure out what the height of that thing is going to be, in order to use those proportions to figure it out. So that's it for our guided practice today. So there is an assignment in Canvas that you can check for, and then an IXL to go with that, and then you are done for the day. So go ahead and take care of those two things. Turn your assignment in where it goes on Canvas, and then also turn in your IXL into where that gets turned in on Canvas. Thanks, and I will talk to you guys on Monday, and I hope everybody has